All right, hello everyone. Hope everyone's doing well. I'm Professor Caudill. Today we are on 63C. Okay, so we want I along F. So this is I, this is F. We want the projection of I onto F. So I don't need that. So as we know, this is the same as saying I dot F hat dot F. And we built a calculator for this last episode. I'm sorry, it's times F hat. So we need to find, first we need to find the values of I, but this projection formula is basically this. A dot, or I hat dot F hat times B hat. So I guess I should say times F hat, because you can do, because this will be a constant. And you can multiply constants by that. Okay, so let's get our numbers. So we know I hat is 1, 0. F is going to be cos, is going to be 180 plus 32, 10, 20 cosine 2, 10, and 20 sine 210. So that is 20, 210, negative 17, negative 10. Okay. Now, the calculator finds F hat automatically, but if you really need to know how to find F hat is basically taking the F vector divided by the square root of F dot F, which is the magnitude. So another way of looking at this is you're taking F times the reciprocal of that. Or you could write it's a negative 1/2. So A is 1, 0. B is -17, -10. So this is our B hat, this is our A hat. A hat stays the same. I mean, it's not that we don't necessarily use A hat in this unless we were doing it if it was flipped in a different direction. So the dot product, we're not doing the dot product, we're doing projection of I onto B, which is 0.7 and 0.4. So we can draw this out. So we have -17, -10, and then we have our unit vector, which is 1, 0. So we're trying to find the projection, if this would cast a shadow, so thinking it would be something like that. Let's double check. Projection of I onto F is notated as yes, that's correct. Projection I onto F. We're projecting the vector I onto the subspace or set F. What does it mean geometrically? Spelled that wrong. Represents a shadow or orthogonal projection. Okay, so it wouldn't be on this because this is 1, 0. I is straight horizontal. So it's saying we would have something like this. It's the point on F that lies closest to I in terms of distance. Is the projection always in the direction of F? Okay, so this would actually be a straight line with F. And if we've seen from other examples, if you're doing a projection, that's also that. So this is B and this is A, and you're projecting B onto A, then that's going to be in the same direction as A. Okay. Next up, F. So now we're going to swap them. Projection of I onto F. which is f dot I hat, but that's redundant, times I hat. Yeah. So this is actually a f hat. My bad. So the projection, whatever is in the parentheses here, will be the first over here. So we're just going to swap these. Okay, so I guess I didn't have to do that. So I could have changed this to B. Oops. I could have just changed this to B, but the way I've coded it is it gives me projection of B onto A. So what does this mean? So here we are taking, if this is I and this is F, up here we did I onto F. So now we are taking F onto I. So what's orthogonal to that? It's got to be in the direction of I. So it's going to be negative 17. Projection of I. Projection of F onto I. I onto F gets us this. F onto I gets this. Okay. Moving on, 64. Find angle between the vectors. Okay, so D. So how do you find the angle? So the angle between these is going to be the inverse cosine or a cosine. I'm not sure which notation I like more. The only problem is this is if you have like a variable a, then it's not as clear as this. And usually you want to be as clear with minimal. So when I write cosine 1, how many strokes is this? 3, that's 5 strokes. And then a cosine, that's 4. So it's kind of like, depends on the context, I guess, but when in doubt, probably cosine -1. So you're going to take d dot a and you're going to multiply the magnitudes. Find the angle So what is this? So we're doing a cosine a dot b divided by square root a dot a times square root b dot b. Okay. So 2.6. Okay. Times pi over 180. $150. Okay, so I could either ask ChatGPT to check my code, but I can also just check it analytically or geometrically. So we have -3, 1, 2, 3, 4, and -3, 1, 2, 3, 4. So they want to know the angle of this. So I'm sorry, they want to know this angle here. So definitely doesn't look like it's 150 degrees. Looks more like 90 degrees. So how to rewrite it so it converts radians to degrees. Pi 180 over pi. Rewrite it, but with simpi. There is no norm function in SymPy. That's lame. Okay. Dot degrees. Okay, so I can do dot degrees. Okay. There we go. $150. Okay. Um, no, -3i minus 4j and 3i plus 4j, and that's an angle of 150 degrees. Go step by step. -7 divided by 25. Did I not plug in numbers right? Yeah, that would make sense. Okay. -3, -4. Man, that's embarrassing. Probably would help if I just put in stuff. Okay, so the angle is 106 degrees. That looks more reasonable. So I do want to use this degrees formula instead of pi over 180. So I do want to update the code. Angle in degrees, angle in radians. Okay. If they're radians, okay. So this should be 143. Radians not defined. Pi Revert to radians. Okay, so maybe there's not. Didn't work. Are you sure? Okay, so ChatGPT is just wasting my time. This should be 143. Okay. Everything 180 over pi. So this is 90 degrees. So we want degrees, direction. Okay, cool. Don't need this eval if. I'm doing the n. Again, don't need this eval if. Okay, so only thing we did was we converted radians to degrees. Radians to degrees. Okay. And I want this to be like that. Do I need parentheses? Do I need an F in the beginning? 160. There we go. Jeez. All right. The angle between A and B is 106 degrees. The positive degree. The angle is 90 degrees. Okay, awesome. So, okay, 106 degrees. I can live with that. So let's move on. Made some cool progress on our physics tools. So yeah, now we're going to do -3i plus 4j my bad. -2i and -2i angle between this vector. So this is like a three-dimensional angle. So D, -3, -4, 2, -4, 1. B is -2, 3, 2. So we want the angle between that. Okay. C two, -4, 1, -2, 3, 2, 2, -4, 1, -2, 3, 2. The angle between C and D. I should just yeah, it's probably easier just to do this. Okay, so what is happening here? So we find the angle. All right, so all right, let me fix this. All right, am I delayed? Testing, 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 testing. All right, I think I'm back. So where are we? We're on 60. Okay, we're here. So we're finding the angle between two. Finding the angle between 2, -4, 1, and the angle between -2, 3, 2. So we're just going to do the same thing, but in 3 dimensions. Three, two, two, 2, 4, 1, 2, 3, 2. Okay, so I'm getting 138 degrees between these 3 dimensions. Now I don't know if they want it, what's the word? If they want it like 90 degrees X, Y, and then 45 degrees X, Z. In physics, this might be more intuitive, but I don't really know. We could draw this out, but usually angles between two usually the angles on one plane. So trying to draw it. Trying to draw an angle, let's see, yeah, something like this. usually we have this angle on the XY plane, and then it's really hard to visualize an angle in 3 dimensions, but we can calculate it 138 degrees for whatever whatever counts. We can still find it. So here's where it's asking it specifically to find the angle that this makes between. So what is this really asking is for is 2, -4, 1. What's the angle? This is D. What's the angle theta between D and I hat, D and J hat, D and K hat. So maybe we can find that. So 2, -4K. 2, -4, 1. Okay, so now we want for I, it's going to be this. So that's 64.1 degrees. So this is very intuitive. I like this a lot more. So this is 151 degrees. And then K is 77.4 degrees. So pretty awesome stuff. So maybe we can visualize this a little bit more. So we have 1 in the Z, 2 in the X, -4, 1, 2, 3, 4. So what's the angle? With the Z axis, so the X. So our vector is something like, you have to like kind of draw a 3-dimensional object. So that's the XY. So the Y will be 1. Okay, so I'm not best at drawing 3-dimensional figures, but so where is this going? It's going, this vector is going here. So it's saying 64 degrees here. I don't really know. It's kind of hard to draw, but we can calculate it. So all right, show 2, -4, 1. show that this is orthogonal to G. Okay, if I recall, orthogonal means the angle between this is A and this is B, then the angle between A and B should be 0. Okay, my bad. 90 degrees because that. So we did confirm this is 90 degrees for the 3 dimensions. Okay. Moving on. Which one are we on? We are on 67. Assuming the x-axis is horizontal to the right. Find the vector products. Okay, so before I make a calculator, I'm going to show how this is done. So A cross C. Gotta convert this into components. So A cross C. So that's 10 cosine 30, 10 sine 30 cross okay, so we're going to get 9, 5 cross 12 or 6, negative 10. So if we do it like this 9 times 10 minus 6 times 5, we're gonna get the J direction first. So we're gonna do 9, 5 cross 6, negative 10. We're gonna take the bottom rows and put them up. Now we're going to do this. Now we're gonna cross it. So 5 times 6 minus 6 times negative 10 equals our I direction. So that's going to be 30 minus 60. So 30 plus 60 is 90. Okay. Now we're going to take this, but we're going to just drop it down one more. So it's going to be 9 times negative 10 minus 5 times 6. So it's going to be negative 90 times 6. Negative 90 minus 30, negative 120J. And let me, I do want to fix that. dot product. Yes, I do want to fix this, if you don't mind. Is okay. Um, so I'm guessing it's just cross. Okay, so A dot B. So we change these to 9 and 5 and 6 and 10. -10. Okay, so when I calculate this, it should be 90, 120. That's annoying. Add a 0 to make it three-dimensional. Okay. That's not a solution I was expecting. So, okay, I guess we'll do C and D. C cross D, so 9, 5. $120. Let's check our math. So we did 5 times 6 is 30 minus 30. 30 minus 60. So that should be 90. Okay. Hmm. Do the cross product of 9 9, 5, no, 6, 10. 9, 5, 6, 10. So I didn't know this. Because the book was having us do 2 dimensions. Okay, so maybe I need to rewrite it. 950 cross, what is it? 6, negative 10, 0. Actually, I need to drop this down. Six, negative 10, 0. So maybe I'm not getting the right numbers because I didn't know it had to be 3 dimensions always. So that means we have to do this 0, 0, 5, negative 10 if we want to keep it IJK. So we're going to get 5 times 0 minus 0 times 10. So we're going to get 0 I plus 0 times 6 minus 9 times 0, 0j plus this 9 times 10. Oh, okay. So we had to fix our thing. I didn't, is it, can you cross more than 3 dimensions? Primarily defined for 3-dimensional. Okay, so you can go in more than 3 dimensions, but it's harder. But yeah, so let's draw this. So we have a vector 9, 5, 9, 5, and a vector 6, 10. So we want to find the vector. So that's going to be, I'm sorry, that is C. No, that is K hat. My bad. So what they got? So yeah, K hat times 120. So I guess I should draw it like, we have this vector, what, 9, 5, so 9x, 5y, then a vector 6x, negative 10y. So saying this is actually going to be negative 120 in the k direction. Where this is c, x, y. All right. What about 9, 5? Cross f, F is 20 cosine 210, 20 sine 210, and 0. Okay. So we have 950 cross -17, -10. So we're going to put these on top, put this on top, 0. So 0, 0, moving this row up here. And then 5, -10. Now we can cross. And this will keep our ijk dimensions. We'll have 0i plus 0j. So we'll have -90 minus 5 times -17. Okay. So let's go and calculate that. And we should have a good kind of intuition. So -17, 10, 0. Okay, so C and D is 5. So -5 times -17, 85. So -90 minus that is 5. Okay, so math checks out. All right. How are we doing on time? 4 minutes left. Let's see if we can do D cross C. So we know C. What is C? We did C earlier. C is 6, -10. C is 6, -10, 0. And okay, I don't think I can do that. I think the order does matter. D. So D is 20 cosine 143. Okay, so 16, 12, 0. Let me give myself some more room. So we're gonna put the rows on top to keep the dimensions the same. So you can look on YouTube. I don't know if anyone else is doing this method. This is kind of something I came up with myself. And I can prove it if you actually watch all of our series, all of the lectures. So we're going to get 0j, 0i plus 0j plus 160 minus, what is that, 60, 72, okay. Okay, so let's verify. -16, 12 cross 6, -10, 88. 88, 88. Okay, 88 plus 72. 8 plus 8, 60, 160. Okay, so that checks out. Yeah, I think I'll end the video there. Next time, I guess we could do 67D for next time. So this I, when we get to the I's, it'll be 1, 0, 0 cross some numbers. And again, we'll have to let's cross it. So it'll be 0A3 minus 0A2 I plus 0A1 minus 1A3 then plus, oh, what is that? A2 minus 0A1. Alright, so yeah, we'll do that next time. So thank you guys for hanging out. I'll see you next time.